Hello friends, let us solve another problem based on the stability number. So first understand the problem. What inclination is required where a filling 12-meter high is to be constructed having a factor of safety 1.25. The soil has C equal to 20 kilonewton per meter square, phi equal to 15 degrees, gamma equal to 17 kilonewton per meter cube. So what we have to find here? We have to find the inclination, isn't it? Let us say the inclination you are representing with I, isn't it normally? So what is the given data? The height of the filling is given as how much? 12 meter. And factor of safety is also given. Let me represent with F. How much? 1.25. Okay. C value is also given. C will be equal to 20 kilonewton per meter square. And phi value given as 15 degrees. And gamma will be equal to 17 kilonewton per meter cube. So what they are asking us to find the inclination. So, but what is the additional data given? The stability number for mobilized. What is phi m represent? Phi m represents the mobilized friction. That means for mobilized friction equal to 12 degrees. So this is not 120 degrees, 12 degrees. For mobilized friction 12 degrees, what is the given data? They have given that stability number that will be equal to 0.063 when the slope is 30 degrees. And also they have given stability number 0.098 if your if your slope is 45 degrees. So we have to find out the inclination. That means here, either it may be 30 degrees, 45 degrees. So for these two inclinations, they are given the stability number. But we have to find out what is the stability number according to our present case. How to find the stability number? That will be equal to C divided by, if we are using the maximum friction, that will be equal, you have to use the factor of safety into gamma into H. So C is given as how much? 20 kilonewton per meter square. Factor of safety is given as 1.25. Whatever the weight density is given, 17 kilonewton per meter cube. Height of the filling is given as how much? I think 12 meters. So if we are solving this, then we will get this value as our 0.078. Okay, now go to the value. Can we directly pick 0.078 from this? We don't have any value. That too, these are the values for the 12 degrees, 5m. But what we are having the angle, 15 degrees. Then how can you proceed? So this is what the maximum friction, but this is the mobilized. How can you define the relationship between these two? Factor of safety with respect to cohesion is how much? Tan phi divided by tan phi m. So if you substitute F equal to 1.25, tan phi is how much? 15 degrees divided by tan phi m. So if you solve this, you will get mobilized friction that will be equal to 12 degrees. Okay. Now corresponding to mobilized friction, what are the values? If your slope is 30 degrees, what is the stability number? That will be equal to 0.0063. If your slope is 45 degrees, then what is the stability number? 0.078. Sorry. What is the value? 0.098. So, but what we have to find? We have our values in between 0.078. So for the stability number 0.078, what is the inclination? How do we proceed there? We have to take the slope of those two. As nothing is mentioned, let us assume that these two are varying linearly. Then how do we proceed? What is the variation between these two? 15 degrees. For 15 degrees, what is the variation between these two? 0.098 minus 0.095. That means 0.035. So for 15 degrees, what is the variation? 0.035. That will be equal to, let us say we are finding up to x. What is the variation between these two? The variation between these two is 0.015. So for 0.015, what is the value of x? You will get it as 6 degrees. So this degree is from where? From 30 degrees. So what is the total inclination? That will be equal to 30 plus 6. That will be is equal to 36 degrees. So in this problem, we have to find the stability number. Based on the stability number, we have to find out the angle of inclination. Okay. So A is the correct option. Thank you.